Okay, so for this problem, we're going to be solving this diagram using similar triangles. Okay, so I did my example here. I want to go ahead and show you based on my example, and then I want you to do the same for this next problem. Okay, so the first thing that I want you to notice, every time you see two triangles inside each other, I want you to break them apart. So this is the big one, and then there's a little one that's inside there, right? This one is it's inside there, but that's what I want you to look at first. But we're gonna see the overall picture. So this one has a 6, has this side, this length. You know what? Let's cover that in a bit. What's this length for the big one? It's gonna be 4, right? I got 4 because 2 plus 2, right? So you have to keep that in mind, because we're seeing the overall picture is, and then on this side, guess what it's going to be? It's going to be 5 plus x. It's not a number, it's an expression. Okay, so I want you to keep that in mind. Okay, so this is going to be 5 plus x, and then on this little triangle, this is going to be x, and this is going to be 2. Okay, so this is what we're going to use a set of proportions to solve this problem. So what we're going to do here, we're going to make two fractions equal to each other, right? This is a proportion. Okay, so on the first one, we're going to use the big triangle, numbers from the big triangle, and on the second one, we're going to use numbers from the small triangle. Okay, so hopefully all this is making sense. All right, let me go to erase this, that way we can start the fraction. So for the first one, we're gonna use the top to the bottom in that order. So it's gonna be 5 plus x over 4 equals, and now the small one, right, x over 2. Okay, before we continue to solve this, I want you to know, to understand that the order matters. Basically, you cannot put 2 here and x in the bottom. You have to be consistent, meaning that if you use this side, this right hand side of the triangle at the top, then you have to use this right hand side of the little small triangle at the top. So you see how they're both at the top, right? So I want you to understand that you have to be consistent. If I use the bottom of the triangle in the denominator, then I have to use the bottom in the denominator for the other fraction. Okay, so there's a consistency there, right? And you don't have to choose the top to go on top or the bottom to go on bottom, right? You can be consistent in any way. So somebody else, let's say you solve it using this method, somebody else who does this also still gets it correct. So pay attention here. Basically, they use bottom, they put the 4 at the top, and the right hand side, this side, they use it on the bottom. And they're consistent because on the next one, they're gonna use the bottom at the top, and this x, the right hand side, on the bottom. Okay, you see how I'm being consistent? The bottom with the bottom, right? These are the bottoms, and then these are the tops, right? Or the right hand side of the triangle. Okay, so hopefully that did not confuse you. I want to make sure you understand that there has to be a consistency here, meaning that you have to use the same number relative to their position. So let's say these two are at the top, right hand side, and these two are in the bottom. Okay, so hopefully that makes sense. And also the other way. What I mean by the other way, it's, let's say you use these two, the two bottom ones with the two right hand ones. You can also do that, like 4 over 2, because are the two bottom ones, and then the two right side of the triangle. So it's 5 plus x over x. all these, notice that they look different, but they're all going to give you the same value of x, meaning the same answer. Okay, so hopefully this does not confuse you. This is not confusing, and it's just making things clear, right? Just keep in mind that you have to use the same order, basically, right? Being consistent, top with top, bottom with bottom, or side with side, and bottom with bottom. Okay, so now in order to solve this, we have to multiply diagonally. So we're going to multiply 4 times x. 4x equals, and then you'll do 2 times this expression, 5 plus x. Okay, you could have also done it the other way, basically multiply 2 times, instead of writing this right here, what I wrote, you could have done the other multiplication first. 5 plus x equals 4x. The results are the same, right? You just have things on the opposite side. Okay, so don't be afraid of how you're gonna do it, right? There's no really order here, as long as you multiply diagonally. So if we distribute here, correct, this would go with this, and this would be multiplied to this. Okay, so let me go on to this side. We're gonna get 4x equals 10 plus 2x, and then I go ahead and subtract 2x on both sides. I subtract 2x on both sides, and you have 2x equals 10. I divide by 2. I'm running out of space. Divided by 2. That does not look like a 2. Alright, I don't think I can write that low. Divided by 2. So x equals 5. So there you go. That's it. Okay. So I want you to do this one, the one that you're given here, this one. And I want you to apply the same rule. Okay. And then let me know what you get.